Hi. Hello, everyone. Welcome to Accelerate Data Preparation for Machine Learning with Amazon SageMaker Data Wrangler. I saw some of the friendly face down there, so hello. And for the rest of you, thank you for coming to the session. I really appreciate you being here. My name is Hương Nguyen. I'm a senior product manager at AWS. And my co-presenter today is Arun Shankar. He's the senior AI/ML solution architect at AWS. Quick question, since I know we just had lunch. I need your help a little bit. How many of you have seen Swami keynote yesterday? Awesome. How many of you have seen Data Wrangler announcement in Swami keynote? Awesome. Some of you caught it. Great. We have some exciting announcement in our session today as well, so looking forward to sharing that with you. We have a very action-packed agenda for you today, starting with why data preparation and the common key challenge with data preparation in machine learning. Then we'll discuss how Amazon SageMaker Data Wrangler is purpose-built to address those key challenges. We'll dive into the key capabilities, as well as the latest launch that will enable you to accelerate data preparation in your organization. Then Arun will demonstrate Data Wrangler capability in action with a real-world use case. Then we'll open it up for Q&A. And we're happy to hang back afterward as well to answer any question that you might still have. So let's dive in. Why data preparation is important for machine learning. It is one of the most critical part of the machine learning workflow because machine learning model is only as accurate as the data you use to train it. Any machine learning project, after you define the business problem, will start with data preparation. Normally, you need to first collect enough data to prepare for machine learning. So this normally involves connecting to multiple data sources. You then need to quickly understand your data using analysis and visualization to especially identify any data quality issues. You need to check for bias, and then clean your data before you can create features for machine learning. Once your data is ready, you then export the features into a location that is accessible for training, and hopefully register the features in a feature store so that you can reuse that for future machine learning model without having to re-prepare the data. However, the data preparation process doesn't stop there. It is repeated throughout the life cycle of machine learning. Once you train the model and you check the accuracy, you might find out that there are problems and bias with your model that can trace back to the data that you used to train. So you then have to go back, iterate, clean the data, and then retrain the model. That's very expensive. Once you've verified that the model meets all the business metric and performance metric, you can then register the model and deploy it into production into an endpoint. At this point, you also need to apply the same data preparation flow on the production data so that you can generate features and the model can consume and generate business insight. After months or weeks, even, the data will change and your model will get out of date. You will not get as much as accurate data as the beginning. So you then have to repeat the whole process, collect new data, re-prepare data, and then retrain the model. So many research indicate that over 2/3 of data scientists' time is spent in data preparation for machine learning. This is a problem because you want most of the data scientists' time to spend building and training model. So to help with this problem, we've talked to many machine learning practitioners and data scientists and customers to understand why data preparation is so time-consuming. There's 4 themes that emerge. First of all, there's multiple tools that you need to use to prepare data, which require learning curve, context switching that add more time to your data preparation process. More importantly, most of these tools are general purpose data preparation tools, not built for machine learning. So you then have to write a lot of boilerplate code, which are not difficult, but tedious and time-consuming, taking time away from building the model. After multiple iterations, as we've seen before, it's also hard to keep track of what are the core operations that you've done on the data and what you need to retain as a recipe so that you can automate it in the future. Next, it's difficult to scale from experimentation to production. The same code that you use to experiment on a small subset of data cannot scale to run on millions and billions of rows of data. You normally have to switch to a more powerful tool like Spark, which many data scientists are not familiar with. Similarly, it's also difficult to bring the data preparation process into production to automate. You normally have to refactor the code, make sure that it's performant, so that it can run in production efficiently. Both of the last step normally require skill that many data scientists does not have. And so you have to bring in machine learning engineer or DevOps to help, which lengthen the time to bring machine learning from experimentation to production. So Amazon SageMaker Data Wrangler is the fastest and easiest way to prepare data for machine learning, because it is purpose-built to address all these key challenges. First of all, it is one single application to help you prepare data end-to-end, from data import, analysis, data cleansing, feature engineering, and production. It is a no-code, low-code tool that removes most of the need to write code, boilerplate code, to visualize data and transforming data. With 300 plus built-in transformation, most of the time you don't have to do that. It is also very scalable to large data set. The same data preparation process you've done interactively can be then scaled to run on a processing job infrastructure backed by Spark. And finally, it's easy to operationalize. You have all the tools you need to automate, like scheduling job and integration with SageMaker Feature Store and SageMaker Pipeline to automate as part of the end-to-end machine learning workflow. So let's take a look at how SageMaker Data Wrangler works at the high level. It divides into 5 key functional areas that help you complete the end-to-end data preparation process, starting with connecting to a wide variety of data sources and browse and select data using a SQL interface or a visual interface. You can then quickly understand your data using built-in visualization and analysis template, and Amazon SageMaker Clarify to help detect your bias. Once you identify all the data quality issues, you can then quickly cleanse, enrich data, and then create features with a 300 plus built-in transformation. Once you believe that the data is ready, one of the key differentiators that Amazon SageMaker Data Wrangler provides is the advanced analysis that can help you predict the model performance if you train the model with the current data. This can help you save hours or days of training model with bad data. Finally, you can operationalize with ability to export data and automate with scheduling job and SageMaker Pipeline. So the key takeaway from this picture is that it is a multi-step process that Data Wrangler enables you to complete and iterate in whole or in part as you need to prepare high-quality data to train high-quality machine learning model. Next, I'm going to jump into each of the key functional areas, starting with collecting data. Traditionally, in order to collect data for machine learning, you need to connect to multiple data sources using multiple tools and read data in various formats. This can be very time-consuming and introduce a very high barrier to start any machine learning project. Data Wrangler makes it easy by enabling you to quickly connect to multiple data sources from the one single interface. With native data connectors to the most popular data sources like Amazon S3, Amazon Athena, Amazon Redshift, Snowflake, and Databricks. In September, we also partnered with Salesforce to bring in Salesforce Genie connector for customer data from Salesforce for machine learning. And today, I'm very excited to announce that we now support Amazon EMR as a big query data engine to bring in vast amount of data for machine learning. You can now connect to EMR Presto endpoint, and we are previewing the EMR Hive endpoints and they will soon go into production as well. Once you connect to the data source, Data Wrangler will read the data in various formats on your behalf. You can see all the lists here. And then, more importantly, you can preview the data, explore it, view all the metadata, and select the data using a visual interface or SQL Explorer. For vast amount of data, Data Wrangler will automatically sample the data for you for the best interactive experience. By default, it will do top K sampling, and you can configure to use random or stratified sampling instead. And you also can configure the size of the sample data as well to make sure that the data is representative of your data. We continue to hear from customers that they need to bring more and more data, especially from third-party applications, in for machine learning. And this is currently a very complex and expensive process because they have to use third-party application to do that, or build their own solution. So with great pleasure, I get to expand on the announcement that Swami called out yesterday in his keynote. Data Wrangler now supports over 40 third-party applications as data source for machine learning using Amazon Airflow. For those of you who are not familiar with Amazon Airflow, it is a data transfer service that enables you to map data from third-party applications like Salesforce, Google Ads, LinkedIn, and many more, and map it into an S3 or a Redshift database. You can then register the data in the Glue data catalog, and as soon as that happens, Data Wrangler will automatically show all this new data source to your machine learning practitioner. They can then seamlessly explore and import data using the same interface that they have with other data sources. So, seamless way to import more data for machine learning. Once you have the data in one single place, the next thing that you generally have to do is understand data and identify quality issues. This generally requires writing boilerplate code, and Data Wrangler makes this easy by bringing in popular visualization and analysis template by default, and you can quickly configure in a few clicks to show you the insight that you need. More importantly, it also provides advanced machine learning power insights such as Quick Model. Quick Model will actually run an XGBoost model on top of the data that you have and generate metrics like accuracy score, F1 score, confusion matrix, and feature importance to help you understand if the data that you have actually is going to generate high-quality machine learning model. This can help you save hours or days of time training machine learning model with bad data. Earlier this year, we also launched the Data Quality Insight Report, which quickly became one of the top used analyses in Data Wrangler. It automatically generates analysis and visualization on your behalf and use machine learning power insight to identify key quality issues that you have to address in your data, such as outliers, missing data, and target column-specific issues like skew target and red class that will affect your machine learning model. It also includes the quick model inside as well. The thing that our customer really like about this report is that it's very actionable. It will also recommend you the transform that you can use in Data Wrangler to fix the issue. You can then also use this as a snapshot before and then at the end of the transformation process to identify any other issues or validate that this is going to be high-quality data. And today, I'm thrilled to announce that we will also generate automatic visualization as soon as you import data into Data Wrangler. As you can see on top of the data table here, Data Wrangler would automatically generate bar chart or histogram based on the data type that it detects. And then it also identifies missing value and invalid value for you using the stack chart up top. So at a glance, you can quickly identify the data columns that have potential issues that you need to dive into. Once you understand your data and identify data quality issues, The next step is to clean the data and create features to train machine learning model. And this, again, traditionally require you to write hundreds or 1,000 lines of code just to do basic operation. Data Wrangler enables you to do that without writing any code with 300 plus built-in data transformation. You can do the most common operations, such as managing column, handling outlier, handling missing data, to the more advanced machine learning power analysis and transform. For example, one-hot encoding, balancing data, featurizing text. And this year, we added more transform to cover more ML use cases, such as time series data that can featurize your datetime and extract up to 800 features. You can use train test split to split your data in training and validation tests, and many more like dimensionality reduction, multicollinearity, and smooth, and more Arun will show you. We also use customer feedback to continue to improve our usability for the data transform. For example, we add the multi-column support earlier this year and the ability to search so that you can quickly find the transform you need among these 300 transformations. We do know that there are still going to be use cases when you need to use custom transformation. So we support Panda, Spark SQL, and PySpark out of the box. And this year, we add the common code snippet library based on popular customer requests so that you can quickly get a snippet of the code, the most common transform, and then you can quickly author your own custom transform or visualization on top of this. So as you iterate and go through the process of analyzing data, cleaning data, and transforming data, Data Wrangler actually automatically captures all the steps on your behalf in a data flow graph. This enables you to easily navigate, view the order of operation, and then quickly modify, edit, and add steps as needed as you go through the transformation process. It also allows you to join and concatenate data from multiple sources directly through a UI to reduce the need to write complicated SQL query to join data from multiple sources. This same data flow is going to be the foundation for you to help automate the data preparation process in the later part of the machine learning lifecycle. Right, now that we come to the end of the data preparation process, you've transformed your data, you validate that it has high quality using the quick model or data insight report. You can now quickly export the data to S3 or SageMaker feature store so that training can actually access it. In a few clicks, you can export data to S3, or as you can see here, you can add your feature directly into feature store as a new feature group or existing feature group. This will enable you to reuse the same features from other machine learning projects without having to redo the data preparation process. Now that you have a complete recipe, including the destination, the next step normally is you need to scale to very large data set. And traditionally, this requires rewriting a lot of the code. Data Wrangler enables you to do this quickly and easily using a UI and API by creating a serverless processing job. You can configure this job to run on very large instance, like an M5 or R5 24x large, or you can configure it to run on multiple nodes in parallel to speed up the process of data preparation. When you scale, multiple transforms such as one-hot encoding are called fitted transform. It will be created to fit a particular data set. So Data Wrangler will enable you to refit this transform as you scale so that it will work correctly on the larger data set. And today, I'm excited to announce that you can now also configure advanced setting for the serverless processing job using the UI in addition to the API. You can configure job partition settings as you write to different destinations, and Spark memory configuration to further optimize your Spark job based on the workload and your data set. Next, we heard from many customers that their data scientists need to automate the data preparation process without the help of a machine learning engineer, either for reporting or to train or experiment. Data Wrangler makes this seamlessly for the data scientists by enabling you to schedule jobs just as part of the same create job UI that you've seen earlier. You can create first a custom parameter for the S3 source path so that Data Wrangler can dynamically recognize new data as they come in. And then you can create a scheduled job so that it can run on an hourly, daily, weekly, or custom schedule of your choice. As soon as you create this job with a schedule, Data Wrangler will then automatically create event-based rules on your behalf so that this job can be run automatically on the schedule that you selected. When the job is running, you can track the status of it in the same job interface that SageMaker Studio provides or the SageMaker console. Next, many of our customers want to also complete the end-to-end machine learning process using a low-code tool so that they can enable more machine learning practitioners who don't have the expertise or want to get a head start using a low-code interface. So this year, we integrate with an AutoML solution that SageMaker provides called SageMaker AUTOPILOT to help you do this end-to-end. As soon as you export data to S3, you now have the option to spin up AutoPilot experiment. An AutoPilot experiment will take the data set that you just created and get your input on the problem that you're trying to solve, as well as the business criteria that you want to use to evaluate the best model. So you'll walk through a wizard that enables you to configure all of this setting. And AutoPilot will also enable you to configure deployment setting as well. So if you want to deploy the best model into an endpoint, it will also do that on your behalf. As it does that, it's also going to package the same data flow that you just generated for the training data set and deploy it into the inference endpoint so that in production, data will be transferred into features that then the model can then consume and generate business insight. So AutoPilot has improved its performance by 10 times this year through various integration with AutoGluon and optimization. So this is a great way for you to speed up the time from data to business insight. And Data Wrangler and AutoPilot can really help you accelerate data preparation and the end-to-end machine learning model. We also know that many of our more mature organizations want to automate the data preparation process as part of a machine learning pipeline, whether it is for feature engineering, training, or inference pipeline. So very early on, we have the integration with SageMaker Pipeline in order to enable you to do this easily through the same low-code interface. This step is normally done by a machine learning engineer, but now the data scientists have the option to publish the same data flow that they just created directly into a SageMaker pipeline. This will then generate a Jupyter notebook that have the code they need to create a SageMaker pipeline object with the data processing step running the same data flow that they just created. They can then easily add training step or feature engineering step or publishing step for feature engineering pipeline. And today, with great pleasure, I also get to announce that we now make the deployment of data flow into inference endpoint much easier using the low-code interface in Data Wrangler. When you export the data flow, you now also have the option to export the data flow into a SageMaker inference pipeline. Similarly, it will also generate a Jupyter notebook with the code that you need to deploy the data flow directly into an inference endpoint. And you can bring your own model in this process, or you can use the AutoPilot inference endpoint or a built-in SageMaker algorithm endpoint. And I will show you all of this in the next few minutes. So in summary, we've just walked through many great capabilities that SageMaker Data Wrangler provides to help you accelerate data preparation in machine learning. Starting with import data from over 40 data source and application. You can then quickly clean and prepare your data using built-in transformation and analysis without writing any code. After that, you can quickly scale to process millions and billions of data without having to rewrite any code. Finally, you can automate with the ability to schedule jobs and integration with SageMaker Pipeline for training and inference pipeline. So with that, I would like to introduce Arun Shankar, Senior Solution Architect at AWS, to help demo Data Wrangler in action. Arun used to be a data scientist, so he's going to tell you the story from a data scientist perspective.
Thanks, Huang. Thanks for the great So thanks for the great overview of Data Wrangler. So Huang pretty much covered all the functionalities existing and the functionalities which we recently launched. So next, what we're going to do is we're going to see a live demo of Data Wrangler in action, right? So we'll see all those functionalities in action. So this is basically the overview of the demo, what we're going to be doing today. So the data set we're going to be looking at is loan default prediction data set. So this is it's a very rich, nice data set. Let's assume that you're a lending company or a bank, right? You're trying to give out loans to candidates or applicants. So you have two scenarios here. Either you might be lending out loans to applicants who will never end up paying back the loan, which means they default and you're going to lose money, or you sort of mispredict, right? So you rejected an applicant who has good historical background of actually paying back the loan in the right time. So you got to make sure that you're looking into the historical sort of data of these applicants and coming back with a prediction model. So that's what we're going to do. So we're going to take the data set which exists in two pieces from S3 and Salesforce. We'll combine them. We'll see how to do joins in Data Wrangler. We'll also see how to do automated analysis, right? So without you doing anything, how, with a few clicks, you can just kick off automated analysis that will run behind the scenes and generate a lot of insights for you. And then pretty much Data Wrangler will guide you from there on, like what are the right set of transformations you want to do. So we'll see all that in action. And then at the end of it, we'll also see how to take everything we did through the experimental phase and then convert it, right, operationalize into processing jobs where we can scale that on hundreds of millions of rows of data. And finally, we'll get to the end part where we'll take the output of Data Wrangler, we'll see how to launch an autopilot job to train a model with it automatically. Perfect, so let's get started. Awesome, so here what you see is SageMaker Studio. So that's our ID, right? Integrated Development Environment for Machine Learning. So it's an environment that just ties all the SageMaker components together. So if you're familiar with it, you would know the interface. So we just redesigned it, so it looks a lot fresher now. Now within SageMaker Studio, there are several ways you can get to Data Wrangler. So one of the easiest ways is you go to Quick Actions from home. You go to Import and Prepare Data visually. Now when you hit that, what happens is it's going to create a data flow file for you, right? So what you see here, the demo.flow, loan default.flow. So it'll create a data flow file for you. And then as the data flow is getting created, you'll see that it's launching the compute that you need to run this interactive session. So I've done that already for you so that we don't waste any time. So you can see that Data Wrangler instance is already up and running. There's also a Data Wrangler app, SageMaker Data Wrangler app, if I expand this, that's up and running. So let's go back to the data flow, which is demo.flow. Now what I also have done is I've taken part one of the data set that is sitting in S3, and then I've actually imported the data set to the data flow. But let's see how to import the data set part two, right? Part two of the data set, which is in Salesforce. It exists as a table in Salesforce. So let's see how to go and actually create a connection to pull that data into the data flow. So when you go and hit Create Connection here, so you're going to see all the native connectors we support out of the box. So S3, Athena, Redshift, Snowflake, EMR, and Databricks. You'll also see the 40+ different data sources for which you have access to. So if you're going to have If you're going to establish access to these data sources through Airflow, you'll see them available right at the top. So in this case, we've already done that for Salesforce. I'm going to go and click on it. And then one of the first things I need to do here is give a name for my connection. So I'm going to call it loan demographics. So part 2 is basically all demographics data, right, about the applicants of the loan. So I'm going to go and let's call it loan demographics, and then hit connect. Now, as soon as you do that, you'll see that it automatically goes and pulls all the databases and tables for which you have access to. So in this case, it's just a single table we have created. Under Data Wrangler database, you can see there's a table that's coming through Airflow. So when I click on it, you get a preview of it. OK, so you can see 4 feature columns here, right? All feature columns are related to the demographics information of the applicant who is applying for the loan. Now what you can do is you can go and apply or write queries here. So this query engine is powered by Athena. So not only you can import data, but you can also go and slice and dice the data, like query this data if you wanted to. In this case, I'm just going to be importing everything. But theoretically, you could run complex queries here, right? Athena queries here. So let's go and run the query. So once I run the query, it's going to go and actually pull all the data in here. You get a preview again, right? The query results. Now I can go and select sampling. Now this is very important. Now our data set is hundreds of millions of rows. Now we don't want to go and actually pull all of that in for this interactive session. What we want to do rather is get a sample of it, right? So in this case, I'm going to go and do the first case sample, right? The first 50,000 rows. You could also do a random sample if you wanted to, or you could do a stratified, right? If you have a lot of classes, you want to make sure everything is balanced. So in this case, because I'm going to be doing a join, I'm going to keep it simple. I'm going to pull the first 50,000 rows. I selected that, and then I import my query. Then I just give a name. So I'm going to call it loanspot2.csv. So once you do that, what it's going to do is now it's pulling all the data, right, from Salesforce table. Now it got it into this interactive session. So you get a preview of the table. You also see options where you can go and add transforms. Now we'll get to the transforms part later. Now let's go back to the data flow. Now you can see that we have 2 data sources, right, that we have imported. So the S3, we imported directly from S3 through an S3 browser. And then we imported the Salesforce, making a connection and then pulling it in. Now what we want to do next is combine them, right? I want to show how we can do joins with these data sets. Now let's go and actually click on this plus icon here, and then hit join. Now once you do that, again, opens up a join sort of a view where you can see options to go and select the other block. And then as soon as you do that, you get a join preview, right? This diamond-shaped node that gets created. So you're seeing that every time you make an action through Data Wrangler, it's translating that action into a directed acyclic graph, right? A DAG. Now you can go and hit on configure here. That opens up another view where you can see the table side by side. So in this case, you can see that part 1 is all the loan data, so loan characteristics basically, right? Things like loan amount, what's the status of the loan, and things like that. And then part 1 is demographics. Let's go and actually select the type of join. So in this case, I'm going to do an inner join on the ID column, because both these tables have the ID column. So this is unique identifier for each and individual rows. And then give it a name. So let's call it join data. Join data set. Right? Hit preview. So you're going to get a preview of the join data set. And then also you can go and add it now to the data flow. So you'll see that what happened now is we basically joined it. Right? So we joined the data set. Now what we want to do next is we have the data in good state. So we have the data ready to now, for exploratory data analysis. We want to do some, right? But first thing we want to do is we want some guidance on it. So that's why we have this new feature called Get Data Insights. So when you hit on Get Data Insights, what it's going to do is it's going to go and say, just tell me what's the target column that you're trying to predict here. So in this case, my target column is loan status, right? So which is this column here, which is a target column. So I have 3 classes here. And I choose classification because I want to classify as part of my prediction model. And then I hit create. Now, when you do that, it's going to take anywhere between 2 to 3 minutes because it's going to run a lot of analysis for you behind the scenes. Now, I've done that already for you because I've played with this data set many, many times. So here in this case, you can see the output, once you create it, will look like this, right? Except you'll have a download option where you can download it as a PNG. Now, I've already downloaded it, so I'm opening up the completed report for you. So it comes back with a lot of things. So we're going to go deep into like each one of these interesting insights that it comes back with, right? So it starts with data set statistics, where it's going to give you things like what percentage of the data, right, has missing values, a breakdown of all the feature types, like the counts. You also get things like duplicate rows. Is there any duplicate rows in your data set? And then also it comes back with warnings, right? So we call these red flags. So every time you're starting with the data set, there's going to be some obvious issues, critical issues that you need to take care of. So what the insights report does is it comes back with those issues, but it buckets them into high, medium, and low. So in this case, we don't have anything high, but you'll see that at the bottom, we'll have a few warnings that are medium. So no duplicate rows, we know that, so not an issue. You can see that it comes back with anomalous samples. So in this case, so these are anomalies in a data set. And also, we kind of rank them by anomaly scores. So you can see that this works based on isolation forest. So you don't have to do all of this implementation, right? So in this case, it's already using isolation forest behind the scenes, looking at your data set, that 50,000 sample rows, right? And then it's coming back with these anomalies. Now, this is something you can drop if you wanted to, or you can take a look at it in depth. The next thing it's going to look at is the target column. So it's very clear that our data set is highly imbalanced here. So from the distribution here. So it comes back with the medium warning saying that there are rare target labels or classes in your data set. So we need to do something about it, right? So it comes back with these prescriptions. So if you read through it, you'll see that it says we need to add more observations, right? Add more data to the data set. Or go and consolidate all the minority classes, so the ones that are really low, right, in percentage, in this case, less than probably 15%. So consolidate them into one class and change the problem type from multi-class to binary class. So you'll get all that insights in here. It even goes and points to exact transforms you can apply when we go to the transform side of things. It also does a quick model. So this is just take this existing state as it is of the data set and see if you can create a model and see if you can split the model, basically split the data set and see if you can come up with a model and come up with these metrics to see how good is my current state of data. We know that current state is like pretty raw. We didn't do any transforms. As you can see that it's pretty bad, right? The balanced accuracy, because that's what we should be looking at, is less than, it's close to like 35%. If you look at other metrics like F-score, the precision recall, you can see that it's good for the majority class, but it's really bad for the minority class because the classes are imbalanced. The confusion metrics tells the same story. We also get an insight here, basically explaining that this is just worse than a dummy classifier, right? If you're going to predict the most class, so we need to do something about it. Now keep going down. You're going to get feature summaries, like how important are your features towards that prediction, right? So this is again a ranked, scored sort of list of individual features and how good they are towards the prediction. Okay, so we see all this, and you can also see other things like distribution of individual features and how it correlates with target labels and all of that, right? Individually, so you can even look at outliers if you keep scrolling down in this plot. But what we really want to do is we want to take all this insight that it comes back with, because it's also guiding you that you need to apply transforms to fix these issues. So let's go to the full complete data flow. So this is the full complete data flow. So here, if you see, let's go and So if you see here, it's a pretty long data flow, right? So we started with importing data, joining, and then you can see that we ran the data insights report, but there's also other transforms we have done. So let's go and actually look at what are the things we did after we completed the insights report. So I've added close to, after the join, I've done 8 steps here, right? So these are based on the report, what we saw. So I'm dropping some of the redundant columns that was created due to the joins. I'm also dropping all the missing values, right? So we have a transform called drop missing. So you can just choose that, select all of the columns, right? Because we have multi-column select. So just select all of the columns and just say I want to drop it. But you also have other strategies. So for this demo, I'm just dropping it. But you can also go and impute if you wanted to, and we have strategies for that. Or you can fill them with missing, just values if you think you have a way to do it, and if you want to kind of fragment them and do it differently. For outliers, you can also do the same thing. Here I've handled all my numeric outliers. So I go and pick all the columns that are numeric type, and then I'm applying the standard deviation, right, as a way to sort of fix it. Here I'm saying that any numeric sort of column with a value that is over 3 standard deviation, I'm going to go and actually drop them, remove them. We can also go and fix some of the rare categories, right? We have a lot of categorical columns in our data set. So we want to make sure that there are, the representation of these categories are sort of, even. We don't want to go and have some categories that are, just very less frequent. It doesn't make sense. So what we're doing is we have transforms to actually do that, where you can go and consolidate. So in this case, for the home ownership, we're saying if you see any category with a fraction threshold, right? If it's less than 88%, I'm going to go and actually just rename it to other, right? That way I'm just creating another new category called other that's just consolidating all the rare categories into one big category. So we do that for the classes too, because that's very important. We saw that we have these 2 minority classes. So we want to fix that. So there's again a transform to do that. So in this case, all we have to do is just go to this column and then rename the charged off, right? But that was one of the minority classes, and then the other one was current. So we're going to go and rename them to default, right? Because these are categories, like the minority classes, most probably they'll end up defaulting. Again, right, this is based on some assumptions. So we do that for both the classes, minority classes. In the end, what happens is we have 2 classes now, but they're still not balanced. So we want to make sure that, can we do some sort of sampling here, stratified sampling, to actually balance out so that we have an evenly balanced class representation. So in that case, we're going to go and apply SMOTE, right? So this is an option where you can go and choose strategies to balance your data set. We have random oversampling, undersampling, and SMOTE. So right now, we have it supported for binary classification. Now, once that's done, what we have done so far is we've taken some actions, right, in the form of transforms. So if you go back to that original data flow, you can see that everything I showed here in that list, all that 9 steps, they just show up as nodes here. Now you want to still validate. You want to make sure that whatever actions you've taken is actually the right actions. So you can just go and rerun Data Quality Insights report again, right? So you can just go and do a second shot at it to make sure that all those issues, what you saw initially, like the warnings, and things with the distribution of the target classes, and even distribution of those numeric sort of features, right? They all look better and different now. So I've actually done that. So I did go and rerun it, and then created a second report, and then downloaded it, which is what I'm showing you here. So you can see here now, there's no missing values, right? So we fixed all the missing values because we did a transform for that. If you come down, like I haven't handled the anomalous samples, so they still exit, but we could have really dropped them if we wanted to. But more importantly, we see that the classes are balanced now. So we converted into a binary class problem now. The quick model, so it's an XGBoost model, right? So it took the current state of the data set now. When we ran it, you see that it's coming back with better scores now. We have only 2 classes, and you can see that it's doing really good for both the classes, right? Almost even performance. The confusion matrix, again, looks better. It's very less false positives and false negatives. More importantly, the feature attribution table looks a lot better now. So you can see that every feature is almost contributing to the prediction. So the plot looks really amazing now. Similarly, you can go and look at individual features and do all of that. But now let's get to the kind of the last phase. So where we are at right now is, if we go back to the full data flow, so we created reports, but we haven't still done any transforms for machine learning, meaning the classic feature engineering transforms you would do. So that's the last batch we're doing here, right? So we're quickly going and actually adding a few more transforms. If we go and actually show that as a list here, So I'm adding, for example, one-hot encoding. So we have a lot of categorical features here, close to 6 features. So we're doing one-hot encoding, and we're saying that for all these categorical features, we want them converted to a vector. So you can also create new columns, but in this case, we're just creating a sparse vector here, right? So it's very handy. You can even go and choose other strategies. If you're familiar with similarity encoding, we also support that for categorical columns. For numeric, what we're going to do is we're going to go and scale them, right? This is like a classic feature engineering step that you should always do is I got all these numeric columns in different scales. Now I want to bring them into one scale. So in this case, we're applying a standard scalar, but you could also be applying all these other different scalars we have here. Right? Similarly, for the dates, we had 2 date columns. What we're doing here is we're bringing in custom transforms. So meaning, I want to take the date, but I want to convert that into a number. So for example, I had a feature called issued on, when the loan was issued on. So it's a date. So it could be issued 7 years before. So I want to take that date and then actually convert that to a number saying how many days since that loan was issued. So we do that by a simple pandas transform. So we take that code snippet and then put it here as a custom transform, right? In this case, pandas. You can also do PySpark. You can also do user-defined like UDFs in Python and SQL. SQL just statements written in PySpark. All that is allowed. We also have a cool feature called templates. So if you're creating custom transform this way, go and search for custom. Right at the top, actually, we have it, so called custom transform. So we have this option called search example snippets. So you can go and actually look at a lot of different possible transforms, right, that you can come up with in PySpark. So in this case, because it's PySpark, for example, let's say I want to go and actually sort by a column or a subset of columns. So when you click on that template, you'll get the code, right, at least to start with, if you want to create your own custom transforms. Now let's go back to our list of things. And then also we applied a few other things, right? Things like I had a text column in there. So we have a way to vectorize that using a count vectorizer, if you're familiar with TF-IDF and all of that. So classic sort of NLP. So we also support that. So at the end of it, we have taken all these steps. So we took data that was pretty dirty, right? So we did a lot of cleansing. So we did DQI, which is data quality insights. We cleaned it. We took some transforms. We validated that. We also added some feature engineering steps that are very specific to machine learning. Now we are right at this point. Let's say that that's the end state we are in. We want to go and actually take this recipe, what we've created so far, and actually scale it. Because our data set is hundreds of millions, right? So it's millions of rows. But what we did here is only 50,000 rows. So to do that, we have an option called destination node. So you click on the plus icon here, and then go and add destinations. There's 2 options we support right now. So these are sinks, right? Destination sinks. Meaning, whatever we've created so far is actually a feature engineering pipeline, right? A data prep pipeline or a feature engineering pipeline. Now we want the output go to a sink, right? In this case, it's an S3 or feature store. So we're going to go and add, let's say, add S3 as a feature as a destination sink. Once you do that, you just have to give it a name. So I'm going to call it output loan data. And then here, just choose a location where you want to go and drop that output. So I'm just going to go and let's say I want to pick a bucket here, that S3 bucket. So let's go with that, and then probably a folder where we want to write it to. Then you can specify partitions now. This is you want to partition your data because this is going to go and actually create a distributed processing job that's powered by Spark, right? So it's a Spark job that will run. So you want to make sure that the data that comes out, if you want it to be partitioned, you can do that. So I'm just going to say 10 partitions, right? You can also partition by column if you wanted to. It's all optional. So add the destination first, right? So just you're saying that I want the output to go here. And then now you have the option to go and create a job. So what you're doing here when you create a job is you just take the same data flow recipe, and then you're saying, I'm going to apply it on a data set which has the same schema, but it's a larger data set. So when you create a job, one of the first things you have to do is you have to say whether you want to refit or not. So things like scalars, right? So we use the standard scalar for normalizing the numeric columns. Now, do you want to go and actually refit that scalar? the count vectorizer we use to handle the employer title. Let's say we want to refit it, and then configure job. So here's where you're going to specify the number of nodes you want for the Spark job. So I'm going to go and specify I want like 10 nodes, right? So I want this huge cluster, and I'm going to take this recipe and then scale it on this larger data set I have. You can go and specify Spark memory configuration. So Huang covered that. You can go and even specify like override like the defaults if you wanted to. There's also ways to parameterize this entire data flow what you've created, so that you can make it more flexible, right? If you feel that your data might change a little bit, or you want to make sure that you can plug in different ways. But right at the bottom, you can also see this option to go and create a new schedule. So when you click that, you see it's going to go and actually show you this option where you can specify, okay, I want it, let's say 1. I want to repeat, I want repeated runs of this job that I'm creating, the Spark job, run every hour because my data is getting refreshed almost every hour, right? If you wanted to. So let's go and create. So when you create, what it does is it just basically creates a job. So behind the scenes, if you go and look at under SageMaker console, you'll see that there's a processing job, right? The job that is running and actually crunching the larger data set. Other things you can do here from this point on is I don't want to actually scale. Maybe my data set is small, but I want to go and actually train a model, right? Which Huang actually showed in the form of a screenshot is I want to take the output of Data Wrangler and I want to go and kick off an autopilot experiment. So for that, when you click on train, it just basically takes you to this screen where you can go and specify, again, right, a location. So this will be a location where the Data Wrangler will write the data to. And then when you hit export and train, what happens behind the scenes is it's exporting the data. And then it's going to go and actually bridge Data Wrangler with autopilot and open up this new interface called create an autopilot experiment. So here you can see that all the fields are pretty much populated, so it already knows where to pull the data from, right? Because this is the transformed data. You can go on to choose other things, right? You can do feature selection here. You can go and choose your target columns, and then go all the way till the end, and then just kick off autopilot experiments, right? So that's one way to end the flow, where you're saying that I'm just going to go with a sample output, but I'm going to go and kick off autopilot experiments. Now you can also go and do other things here. A lot of times, developers and data scientists, they want to look code, right? So far, everything we did was actually through the visual interface. But what if I want to actually do the same thing through code? Because I want to make it as part of a CI/CD, right? I want to do the same processing job. I want to take the recipe and then do the same processing job, but I wanted to do it in code. So we also give you this option to export it as a Jupyter notebook. So in this case, when you click that, that's going to create a notebook with all the code that actually will go and create the processing job and then write the output to an S3 bucket, right? So this is the code. So you can go and modify this code and just execute it. So you have that option. You can also export it as pure Python code if you wanted to. So there's an option to export it as pure Python code, export it to feature store. And then we saw that you can also take all of this and then bundle it into a pipeline, right? So SageMaker Pipelines is an orchestration tool. It's a tool where you can go and create pipelines and orchestrate pipelines, right, and workflows. So when you do that, again, you get a notebook where it'll take this and bundle up into a SageMaker pipeline. But what I want to kind of cover a little deeper is the inference pipeline, because that's a new feature we launched. So think about it, right? So you started with Data Wrangler. So you did your feature engineering. And then let's say you go on to use autopilot or your own custom sort of modeling strategy. You go and train a model. Now you want to go and deploy this model. You want to create an endpoint of this model so you can make inferences. Now at that point, when you're making inferences, you have to make sure that your incoming payload goes through the same steps or same set of transforms to what your training data went through, right? So that's an important step. So until now we didn't have a out-of-the-box solution for that. So you would have to go and actually create a container for that, like take the data flow and then figure out how to go and actually apply the data flow to your incoming payload. So with this option, they export to SageMaker Inference Pipeline. So we're going to allow you to go and actually do that automatically. So when I open this, let's open the notebook. So I already have it here. OK, so here you can see that this generated notebook, if you go all the way down, it's going to ask only for a few things. So you just have to point to the location where you have your trained model. Now, this can be an autopilot trained model or your custom model or a model just using any of the built-in algorithms, right, we support. So you specify the location of the model, and then you go and actually create an inference pipeline, right? It's just 2 basic steps. So when you create an inference pipeline, it creates something called a pipeline model. So it's basically 2 containers. So you have a pre-processing container which takes the data flow, and then it applies that steps, all the steps, right? So it has all the scalars and everything in there baked in. It's going to apply it on the payload, and then pass the transformed payload to the prediction container, which is the second container. That is going to be, the one that's going to leverage your model. Finally, there's also other options where you can go and import data sets directly, right? So we didn't show that, but there's also ways. Let's say, I don't want to do all of this. I just want to go and export it directly to S3, so we also have an option for that. So now that I think pretty much sums everything we wanted to cover today. So we started with data set that existed in 2 pieces. We combined it. We went through some cool ways to do automated analysis. We saw how to fix data, clean the data, and then do feature engineering with the data. And then finally, we saw all the different ways you can operationalize the data, right? Like scale it to larger data sets, create models through autopilot, and also saw how to do inference pipelines, right? Which is basically getting all the way to the end, which is endpoints. Now, what we want to do now is just open up the floor. If you have any questions, feel free to get up and ask your questions. It can be related to the demo. It can be related to any of the things Huang covered. So we'll make sure we get it addressed. Thanks, everyone.